Okay, so all right, so the third videos, this is the third video, and like I said, I'm going to say reintroduce myself as Mr. Babatunde Following Show, the technologies in charge of your microbiology lab MIC 221. So this is on it's not limited to MIC 221. It's also it can be useful for you anytime. So you can keep the video and use it whenever you like. Now the third one, the third this third video focuses more on our second practical that we did, and basically I think our interest was on isolation. Basically it was microbial quality control. We are interested in quality control, and the particular procedure that we worked on was the isolation of bacteria from milk and water samples, and also it is isolation and enumeration. So we isolated and we are going to what enumerate. So I'm just giving you to help you coin your topic or your title very well. Now, the theory notes that on a plate, the maximum number of colony forming unit that you are allowed to have on a plate is 300, and the minimum that you are allowed to have is 30. So it will begin 30 and 300. Between 30 and what 300, that is the that is the minimum and the maximum number of plate that you are allowed to have on a. Okay, so find out why. That is part of your theory. That's what I mean by theory. Why is it not, why was it not more than 300, and why was it not less than 30? So that's your theory. Now, another theory is that we are working with water. Some of them are sachet, some are bottled water. So they would have gone through vigorous quality control in the industry before they are produced, so that they are safe for consumption. So tell us, what is the microbial load that is what is the minimum amount of microorganisms that must be found in the water for it to be deemed unacceptable. Okay, so these are the theory that you need to do. So, but my major concern is the quantitative aspect of what you have done. How do you carry out the calculation? So we did serial dilution. Now serial dilution, I wanted to note that in serial dilution, the first two can be 10 raised to the power minus 1, or the first two can also be 10 raised to the power 0. 10 raised to the power 0 is the stock solution. So if you are working with heavily contaminated objects, solids or liquid, the first tube is not 10 raised to the power minus 1. The first tube is what is 10 raised to the power 0. It's called your stock. Okay, so for example, if you're working with soil samples that are very heavily contaminated from soil samples, for example, from the garden, it contains a lot of microorganisms, both fungi and bacteria. So your first, it has to be what? It has to be stock. But because our samples are industrial, they are meant for human